Welcome, folks, to this webinar on building deep agents with Scale AI and Temporal. And don't worry if you don't know much about what constitutes a deep agent, or you're sort of early on in your journey there. And I wouldn't worry about if you haven't seen what Scale AI can do as well. This webinar was born out of me seeing a demo and speaking with Scale AI and trying Agentex myself, and I went, oh wow, okay, there's something here. They're doing a level of sophistication that I think other people might want to aspire to when it comes to their agents, and also a level of reliability that I think everyone wants to aspire to. So without further ado, maybe we go next slide into some housekeeping. Okay, so we're going to shoot for 45 minutes and then some Q&A as well afterwards if we end up with time to do some audience Q&A. There is a Q&A panel that you should see in Zoom. Near the bottom, there's a little Q&A button, and you can submit questions at any time. And I believe we have Josh, who's a solutions architect for Temporal, who's going to do his best to answer all the questions, and then also we'll follow up after the webinar with anything that wasn't answered. We'll put that in the community, and we'll email you with those details. And similarly, a recording is being taken, and we will send that recording to all participants. So don't worry, we are recording this, and we will send that to you. So next slide. Yes, I'm Steve Angelakis. I work for Temporal. I'm a solutions architect, and basically what that means is I work with companies to help them get the best out of Temporal and have the smoothest time using Temporal. And I specialize in AI these days because AI is happening, as we all know, and it's a very exciting space. Yeah, Temporal has a lot of great AI use cases. And with me, I have Daniel Miller from Scale AI, and I think this is a perfect chance for you to tell the audience a little bit about yourself.
Yeah. Hey everyone, I'm Daniel. I'm a senior platform engineer here on the Agentex kind of Scale AI's platform team. And I basically help build and kind of solve real business problems at scale. And I have a kind of a background in backend, infrastructure, distributed systems, and I now kind of focus more on AI and trying to get things out of demos into real production settings. Although today we will be showing a demo, kind of ironically. But
Yeah. So you're about real agents that do real things reliably,
Mhm.
in a sophisticated way, which is cool. Next slide, please. I did want to give like one little shout out before we get going. The AI cookbook is a thing Temporal has released, and we're constantly adding to. Um, this is a series of samples and recipes, so you could think of that as explanations for how to build certain AI tooling, AI patterns, that kind of thing. And like I said, there are more being added every week. And so go to that URL at the bottom or just Google AI cookbook. And I think this is a great way to get started in thinking about how Temporal can orchestrate agents or any kinds of AI use case. All right, so moving on. Today, we are going to talk about a little bit about deep agents. I'll give a brief background on at least what I mean when I think deep agents and how they're relevant to Scale and Temporal. And then Daniel's going to talk about Scale AI's Agentex, and which actually has Temporal support out of the box. And so he'll talk about that integration and also how he thinks about agents and autonomy, increasing levels of autonomy, I would say, over time. We'll do a demo. Daniel will do a demo, and that's really cool. It's going to be a long running, multi-step, self-improving procurement agent. So for like a real kind of building procurement, supply gathering kind of use case. And then I'll interview Daniel a little bit about Scale AI, about agents, about his process of building them, and a bunch of other stuff about AI. So that'll be interesting, I think, and then we'll go into any audience questions we have. All right, next slide. Okay, so a little bit of preamble on where we're at with AI and deep agents specifically. The AI models, as I'm sure you've noticed, are improving rapidly. Um, this graph shows the length of tasks that AI agents can complete successfully using various models. Newer models, the ones on the right, can accomplish tasks that previous models can only dream about. And this is kind of a function of how many steps they can do without sort of going off the rails or failing in some way. And it's also a function of how long they can, kind of chew on context and take steps towards a goal. So it really does correlate to time. You will see that Claude Opus 4.5, has a maybe 5 hours of kind of free flowing agent time and was able to, looks like, train adversarially robust image model, which is a pretty complex thing indeed. So these models are getting smarter and they're thinking for longer and doing tasks for longer, sort of unassisted. Next slide. And for these new models to be able to achieve those tasks effectively, they need to run inside deep agents. So the distinction between a deep agent and a shallow agent, or what I call a shallow agent, is a shallow agent may call a single tool on the way to answer a query using an LLM. So, for example, think about a weather agent. What's a weather agent doing? You're asking for the weather in San Francisco. That the first step it might do is use a tool to contact a weather API and get a response. Very simple, right? Maybe a one-step tool call and then generating, using the LLM, generating that response. The weather is this kind of degrees in Fahrenheit or whatever it is. Um, and that's a shallow agent. It's pretty short process. It's pretty low amount of steps. By comparison, a deep agent is able to do much more to achieve a goal. It might pull context from a variety of different sources, so databases, web searches. It'll be able to plan or break down your tasks, so you can give it sort of like a high level overall task, and it can turn that into kind of a to-do list of items, and the model can chew through those one by one. And so that becomes a series of subtasks or sub-steps, each with their own tool calls, with their own context, that kind of thing. So the sophistication in orchestration is increasing. And then there's also memory. So memory's obviously useful for remembering the agent's progress towards a goal while it's running, so the state. But then there's also long-term memory, and this is for when, for example, let's say the agent learns something. It learns that this path is effective versus that path, or this tool needs to be run in this way, or this data is this sort of kind, and or this context is really important for the next time it runs. You can collect that information and feed it back to the agent in future runs. And this will greatly improve the accuracy. And so you get this kind of self-learning, self-reinforcement process as well. Next slide. Thanks.
Yeah, and I guess one thing here, Steve, the kind
Go
of
ahead.
you're going off, right? Like related to that last slide about time, right? Like it kind of seems like deep agents produce higher value with more time because obviously doing all of this kind of takes more, takes more because it's just there's all these tool calls happening, there's kind of this thinking process, right? So it kind of seems like things are moving in that direction.
Absolutely. But because there's more time and there's more steps, there's more risk, right? There's more chance that things will fail halfway through. So if you go to the next slide, you can see my nano banana produced dystopian image of what when agents go wrong.
Yeah.
So this is kind of talking about an infrastructure failure or a cloud region going down or the process crashing, the process that's orchestrating these agents. Um, the longer it runs, the more chance you have of this kind of problem happening. By default, if you don't save what you do at each step, you're going to need to redo that from the beginning, and that means time, and it means expensive LLM calls, and all that kind of thing. So you need to, as a developer, how you think about how are you going to save state. Like if you crash at step 4, how are you going to retrace your steps up to step 3 without rerunning everything? That's one consideration. And if you go to the next slide. We also have so that what I've covered was infrastructure failure, right? The agent crashing due to some infrastructure problem, but there's also the risk of agents just simply going off the rails. What I mean by that is, let's say step 1 to 3 seems to be accomplishing tasks towards your goal, but let's say agent step 4 has some kind of problem where it gets some bad assumption or it calls a tool and it doesn't quite come back in the way they want to, or the context gets poisoned in some other way. And then all of a sudden that means that it's taken a bad path. And so agent step 5, 6, 7 is now, gone off the rails and it may never succeed. Or if it succeeds, it might spend ages churning to figure out where it's at. And that burns time and also money in LLM calls. And so you kind of have these this compounding problem. And on the left here is a little widget that shows, for example, over 20 consecutive steps. If you only have a 1% chance of failure, that means you're going to have an 18% of a chance of any failure across those 20 steps. And this is what I mean by going off the rails. A failure doesn't have to be an infrastructure failure. It can be a failure of purpose or a failure towards the goal. The graph on the right shows another kind of way of illustrating that concept. You have production reliability, which can get lower and lower the more autonomy you have. So you can think of that as the more steps that the agent takes unassisted, the lower reliability may be. And then also human in the loop systems can help there, and that's what I'll talk about next. But Daniel, was there anything you wanted to say about agents going off the rails?
I mean, yeah, it's definitely a very real thing. And I think like it's exactly kind of what you're referencing here about human in the loop, kind of being able to sort of stop them from doing certain things. There's also kind of guardrails that can be implemented, right, to make sure that there's some sort of programmatic way of stopping agents from doing something. Which is there's all sorts of ways of doing it, but it's essentially just an LLM taking the output or the input of, what's coming into the system and kind of safeguarding that it makes sense so that it's not something too crazy.
Perfect. And so a little more on human in the loop. So one way to ensure that your agent doesn't get lost on step four is to intervene and say, hey, actually, here's some additional context, or I want to interrupt you and correct you on step four, lest you go off the rails. Um, as this GIF kind of communicates, if anyone spends a long time in coding in Claude Code or Cursor, I mean, I think you relate to this image where sometimes you're just sitting there kind of watching the thing cook and then, oh, I need to interrupt it, or oh, I need to change its course. This is this is it's fun. It's a brave new world. It's exciting. I love these coding agents, but I think there's another model we could be shooting for, and I think will become increasingly important over time. So if you look at the next slide, I think where we're going is actually proactive or ambient or background agents. They're called many different things. So what if instead of you sitting there and interrupting and intervening, what if the agent sort of cooked on its own and conducted its own steps. But then, if anytime it was unsure or anytime there was a decision of consequence to make, it kind of notifies you and says, hey, human, can you give me a pointer here? Or I seem to be lost. Or can you approve this action? And that way, you can get your agent back on track, but instead of sitting there sort of, watching and interrupting, you're out doing whatever else. You're going and grabbing coffee, and you get pinged. And so I think this is the world we're actually hurtling towards. Some people are already using coding agents that are kicked off by their phone, so like Claude Code Web or Codex, and there's many other ones that do have mobile capability. And I think we're going to increasingly enter a world where agents spend a long time cooking, and then you just have to steer them. Eventually, which is going to be great for productivity and it's going to be great for everything. I'm very excited about this world. But yeah, Daniel, I'm not sure if you had anything else to add here. And
No, I think that, yeah, that's totally right. I mean, like, I think one thing to mention, which we're going to cover here more, but it's like when you have this capability, it kind of unlocks like nonlinear scaling with human beings, which is like personally, I can't really do more than two Claude codes at a time, but I know some people can do 10. I don't know how they do that, but by having kind of these background agents, right, you can kind of scale them without having to have people in charge of each single one. So you could imagine having maybe six or seven running in the background and doing things for you, and then they just ping you when they need you. So that enables that as well.
exactly. Um, yeah, it's going to be an exciting world. I think that'll be the paradigm within a year or two, maybe even sooner. Things are moving quickly. But Daniel, you on the next slide, I believe you have a way that you and Scale think about agent autonomy, and sort of the levels of AI agency. And when I saw this at a dinner that one of your colleagues presented at, and I just thought it was brilliant. So why don't you talk us through how you think about the levels of sort of AI agency?
For sure. Yeah. I mean, there's definitely going to be a little bit of repetition with what Steve was kind of talking about, but I think it's helpful. So kind of here at scale, right? Like the way we think about AI, right? And kind of the enterprise is in these five levels, right? And so kind of starting at the left side here, this is the simplest way, right? Level one, a simple chat. So this is essentially you ask the LLM a question and it kind of just responds. It doesn't have state. It can't, if you say like, hey, my name's Daniel, it might respond and say, hey, Daniel, how you doing? And then you say, what's my name? It doesn't remember what your name is. An LLM is stateless by nature. Kind of moving on a little bit more complexity, right? Because this is kind of the world we were in maybe 3 years ago. It's kind of level two, right? And so level two is really about saying we're going to arm these agents with some tools, but they're going to be kind of deterministic. So the best example of this is kind of like a RAG system, right? Where you have basically some sort of large corpus and you ask a question about it, and then your AI agent kind of every time encodes your question, finds some chunks that are relevant, and responds with the appropriate context. Level three, this is kind of like where we see actually most enterprises today. And I think this is kind of where the world is today, which is you give an AI agent or an LLM a bunch of tools, and then you can ask anything, and then the agent kind of decides which tools are appropriate in order to help you with whatever you're trying to do. And so what we're trying to do here is we're trying to go towards level four and level five. And so level four, I think still makes, I think most people can still conceptualize this, which is essentially like a multi-agent system. So if anyone's kind of digged into like the internals of a deep research agent, for example, this is a great example. So you could have an agent that takes in the user's query and potentially like creates sub questions. Then you can have another agent which does like kind of web searches and tries to find the right answers. And then you can have a last agent that writes a report for you, right? And so you have kind of these tasks which are isolated. And so that gives higher accuracy. And then those are all kind of put together and then given to the user in a final output that hopefully is better than just having one LLM do everything. And so then the final step, right, this kind of level five self-driving agents, this is, I think, maybe the most interesting, kind of what Steve has already been alluding to. And so this is kind of this idea of ambient or kind of background agents. And so the idea really is that we have agents that are being triggered by external signals, external events, and are sort of just doing work on our behalf autonomously without us having to drive them. Um, that also means they could potentially talk to each other. That also means they could, optimize in the sense that they can get better over time. And so this is way more kind of free flowing and much more of a visiony kind of thing. But hopefully the demo that we'll show today will sort of try to put this a little bit more concretely because I'll be honest, when I first saw this, I was like, what does this look like? Because I don't really like I understand the concept, but I don't really know what that looks like. And so I guess one really important thing to note here, right? For level five, right? For these self-driving agents, without like these kind of systems have to live for a long time, right? Because they're just going to be floating around in the background. And so without a technology like temporal, it's kind of impossible to get here. You need that infrastructure for this to work. You can't just keep a connection alive. You can't keep a server alive forever. If you try to run cloud code on your computer for a long time, like you somehow have to still kind of keep it open. So really like temporal is absolutely necessary. And that's a lot of what we've done here. We've built Agentix really on top of temporal because it gives these guarantees. And there's kind of some other stuff that I think is interesting with temporal, and I'll kind of allude to it here in a second. And so really what we're trying to do at scale, right, is get to a place where we're enabling enterprises to create AI systems and have them floating around their enterprise and doing really useful things for them. We don't just want kind of one individual system that helps. We just want to enable everyone to be able to create these agents that can do really useful things. And so that's kind of what we did here with the Agentix. So this is our kind of solution to get to L5 agents, also to get to a place where enterprises can actually create these agents, deploy them, and have something useful. So the idea with Agentix is that it's basically an infrastructure, like an agentic infrastructure framework, right? So the idea is that it turns out that, writing an AI agent is actually not that hard, right? You can go into Python, use maybe a framework like OpenAI Agents SDK, you can call an LLM, and that's sort of doable. What becomes hard is how do you get your agent to everyone? How do you share this agent? How do you make it actually work in a real enterprise setting, right? And so it turns out there's a bunch of things that you have to worry about. You have to worry about like your kind of input and output patterns as far as like your actual like API calls. Streaming is super important because at the end of the day, latency is a big thing with LLMs. So having streaming kind of takes care of that. Where are you going to host these actual like agents? How are you going to scale them? What happens if there's a lot of traffic? How do these agents talk to each other? How do you talk to your like, how do you go in and use a database or how do you keep secrets? All this kind of stuff, right? So what we've done here at Scale is that we've built sort of like a platform as a service, right? Where we say, look, you can write your code. You are your best SME. You know what the problems you're trying to solve. So you worry about that part and everything else around that, which is kind of all that noise that really is a lot of work and you have to do every single time. We'll take care of that in kind of a repeatable way, in a uniform way that kind of helps you unlock this potential of creating more agents.
Yeah, and I think there's kind of a race where everyone's trying to create their own sort of age production ready agents. I have many conversations with many companies, and they're all kind of building, I would say, the same plumbing for these categories that you see on the left. And so, like, I think any framework that removes that undifferentiated lifting from these companies is just gonna it's just gonna be a win. You get to keep the essence of what you want your agent to do, something that's very business specific to you, works on your context, works with your specific tools, but like the rest of that right now is something that a lot of people are concerned with and churning away on, and in my opinion, they shouldn't have to. Like, there's no reason why you need to come up with your own version of streaming updates, for example. Like, it just makes no sense. So yeah, I think frameworks like what Scale's doing here with the Gentex is just a huge help.
Yeah, thanks, Steve. Yeah, and I think what's important to distinguish here, right, what Agentex is not, right, is that we're not trying to replace OpenAI Agents SDK or LangGraph. We're not telling you how you orchestrate your LLM calls. We're not telling you how you should do your business logic. That's all left to you. You can do that however you want. And we're also not really prescribing a cloud vendor, right? So it's really about the way we built this was very much on purpose, like unopinionated, because we believe that AI is changing so fast. We didn't want to box ourselves into something, create something that, in 3 months becomes irrelevant when a new kind of technology comes out. So this is all kind of open and unopinionated by nature. And I think this brings us to like a really good point about temporal, right? Which is like, why is temporal so important for what we're doing here on Agentics? And so I think there's like a few things, and these are kind of real world things I've seen where temporal has been a huge unlock. Um, I think the first thing is like a lot of times enterprises run agents with kind of batches, and kind of also in some schedules. Like for example, they might have an agent that periodically, maybe every day, goes in and checks like a bunch of websites to see if, I don't know, something about an advertisement has changed, right? And so having temporal that does two things. One, it allows us to schedule this, right? Like if not, this means that you have to go create your own infrastructure, cron jobs, all this kind of stuff, which just becomes a mess when you're just trying to think about your, kind of agent logic. And the other thing it does is that when you have so many LLM calls happening, right? If you have 1,000 events that have to run in a day, you need to have a way of knowing that that is going to be not, that those things are going to be retriable, that it's not going to be brittle, that it's not going to be something that just breaks down. And so it really becomes essential when you start scaling things up, and that's where temporal really shines. And I think kind of the second part of this is like anytime that you have a tool call or something that's a little bit more than just like getting the weather, right? Like for example, if you want to do like you want to like move money from one account to another account, um, that is typically a two-step thing, right? And maybe even more, but like you're essentially withdrawing money from an account and then you're kind of putting it into a different account. And so there's two steps there, and you can't fail midway. Like you can't just say, oh, sorry, I lost your money. Like we have to call the tool again. So there has to be a way for the tool calls to have it like the kind of how temporal defines it with activities that to make it idempotent and retriable, to give us those kind of guarantees that like in an enterprise setting, we can trust these agents to do these real things. So it's really like I think, temporal really gives us those capabilities, and that's kind of the reason we built on top of this.
Right. And you don't want to restrict the agent. You don't want to really restrict what it can do, and you want it to choose what tools it wants to choose and reason in the way it wants to reason. But there are certain things you need guarantees for. Like I talk to very large enterprises sometimes who have like very real compliance sort of requirements and things like that. If and so like a transaction, that two-step payment transaction now becomes something that you're breaking compliance or even the law if you can't guarantee, or if there's no audit trail, and so like yeah, again, this is a way of having agents be effective, but in a way that you can control the bits that you need to control.
Exactly, exactly. And yeah, with that, I think it'd be interesting to move on to the actual demo piece. I think this is kind of more fun. But before we get to the demo, I want to talk about really quickly, like just a little bit of background for procurement agents, what procurement is. I think it's important to kind of set the stage. So, procurement is basically this kind of action of acquiring goods, and for this demo, we're going to be looking at like building construction or like office construction, right? Any really construction, right? And so you have like windows, HVAC units, steel beams, all these kind of materials that have to come in order to build something. And so maybe like 30 years ago, like the way this was done was that there was someone who was like on a phone calling people, like trying to figure out like, hey, has this come in? Has this not? Like, where are those like windows that we ordered? Obviously, we've gotten better than that. We have like now we have like kind of ERP systems, right? Where it's like we have a software that kind of automates that process where you can see what's going on a computer and you can potentially like enter things into a database yourself or maybe use a UI to enter things. And so that's great. Obviously, we've gotten better. But there's still kind of one fundamental issue here, which is that like these ERP systems, like most traditional software, are as good as you can specify, right? So you can create all these kind of if-else statements, all these kind of branches for things, how you expect things to go. But the truth is that the world doesn't work like that. Unexpected things happen all the time. And so that's why you have a human being there, kind of making sure that things are working as they should. And so the kind of pitch here and kind of what we're thinking about when we think about these long running agents is why don't we just have an AI system that takes that place, right? And so we're not saying we're not removing the human being. We're just saying let's move the human being a level higher, right? Let's have the agent coordinate all these things, make sure things when things go wrong that it maybe can self-correct. And then if things are very ambiguous and it's really not clear what to do, then we escalate to a human being who can go ahead and kind of make the right appropriate action. So let's go ahead and show that. So here we are. This is our kind of like we're running this locally right now, just for the purposes of this demo. But this is kind of Agentex. This is our UI. Has a bunch of kind of reusable components. But yeah, on the left here you can see like a bunch of different constructions and different buildings that we've done. But let's start a new one. Let's say like Scale AI, like office reconstruction or something. I don't know. And we'll
And
just
Daniel, is it possible to blow that up a little bit as well?
yeah,
Just the text. Thanks.
yes,
Nice.
awesome. So let's go ahead and get a very like simple sort of a simple workflow started. Awesome. So we see here things are starting to happen. So okay, so there's a submittal approval for some beams. Okay. And so the agent immediately starts responding, right? It starts really doing things. It issues a purchase order, which is a very normal thing to do in construction. And it assigns kind of this ID for it. Also, it's kind of in charge of this database where it's updating kind of the status of, in this case, these steel beams. And it also has this context of this project schedule. So this is kind of like the overall like construction project, like where things should be going. And so we see here that the agent is kind of taking actions on our behalf. And I think what's important to highlight with this demo, right, is that obviously this is happening maybe in the span of a couple of minutes, but building construction takes like weeks, even months. So this is where like if you don't have something like Temporal that can really like hold on to these long running workflows, like it's really hard to do this. Or maybe you do it in a very like kind of um like not so efficient way, maybe just like with a database, which is like can be done, but it's just not as like bulletproof.
Right,
Um,
right. So in reality, like these steps that we're seeing here could take weeks
yeah,
actually in real life to execute. And so therefore you need some kind of persistence of state and all that kind of stuff. Like you basically need to make sure that you don't lose something on day three because someone restarted a server or a Kubernetes pod or something.
exactly, exactly.
Right.
And so like and you can kind of imagine, right? Like after each of these steps, it's like the agent kind of goes to sleep and it kind of waits for more signals, right? And so as we see the things happen, right? So it's like, okay, so there's like kind of these steel beams that leave New York, suspiciously close to where my house is, and then they kind of arrive in San Francisco, kind of at where where Scale AI's office is. And so the agent is actually pretty good in the sense that it's like kind of proactive as well. It can kind of flag potential issues, maybe things that a human being would even miss at times because there's so much going on. So it can kind of keep track of that. And so in this case, right, this is kind of our happy path, right? It's like, okay, we got these windows, these steel beams, the inspections have passed, everything is going well. And yeah, everything kind of worked. And so we don't have to be watching this agent, right? This agent is kind of taking these actions on our behalf. I think maybe it's useful as well to see what happens when things go a little bit wrong, right? So let's do like, not to put you guys on the stop on the spot here, but like let's say Temporal has a reconstruction that they are doing for one of their offices or something. And so let's do a different example here. So, also here in the background, just for the sake of transparency, what I'm doing is I'm actually running a small script that is triggering these events. Obviously, these events would be this is being done through signals, through temporals kind of signals. This would most likely be done through like external software systems that would be hitting our system, right? But just since this is a demo. So we see here, okay, these HVAC units, it's kind of, it feels similar, right? It's like this kind of same flow where it's getting these items. And so we'll see here in a second, things might go wrong. And there it is. So basically we have an inspection failure, right? So this means that the HVAC units got to the site and something is wrong, right? And so basically the question here is like, should we reorder the item and update the master schedule? And that is actually exactly the right action to take. Because at the end of the day, right, like if something if we've failed an inspection, like we do want to reorder it. And also like this master schedule has to change accordingly. So we'll say yes, and our AI agent will do the right thing. I guess what's important to note here is that like, and there it goes, kind of using tools in parallel, making sure to do these different things, and then it starts, creating this new purchase order. I think what's important to say here is that like, although in this case it kind of did perform the right action, right? We can also imagine a scenario where maybe it says, "Hey, I'm going to reorder the items." But then us as a human being, we might say that's fine, but like also make sure you update the master schedule, right? And so what our AI agent can do is that we have like a second LLM that's watching what's going on. And so every time a human being steps in and does something, it kind of extracts this learning, which in this case is like, okay, look, if an inspection fails, you have to remove it from the schedule and update procurement records and issue a new purchase order. So then the next time around, when a failure happens like this again, the agent is better equipped to solve the problem. So it's sort of like this kind of optimizing nature that Steve was talking about, and that I was talking about, even with like the L5 agents. Like this is kind of what we mean, right? Where it's like the more you use this agent, the better it gets in the sense that it kind of understands how to do things. Because like, I guess the best way to think about this is like if you have a junior procurement, person, right, and something comes up and they ask their manager, "Hey, like, what do I do now? This failed." Normally, like they won't ask that same question again if it happens again. So like that's the same idea, right? We want this AI system to be smart enough to say, "Yeah, like, hey, I've already seen something like this. I know what to do in this situation."
So,
Um,
so to recap on that, like just quickly, yeah, if you go up to inspection failed, a step clearly went, wrong or not the way it was supposed to go, and then so this caused the agent to essentially pause on that step for that HVAC step, and then reach out to you and say, "Hey, there's been an issue here." Not only did it reach out to you, it was like, "I think this is probably the action that you should want to take." Like, so it suggested something. So instead of you having to say, "Oh, I want this, this, and that. This is the corrective action." You were just able to review what it suggested and say, "Well, actually, yes." And then when you took on its suggestion, the learning supervisor kind of agent went, "Oh, well, actually, that's a lesson for the future, like, or potentially that in this situation, it looked like we approved reordering the item, and therefore we're going to note that down. And then that probably becomes a stronger suggestion the next time it happens, or even might even become an automated action. I don't know, but that's again this like kind of self-learning process is really interesting to me.
Exactly, exactly. Yeah. And then this is obviously like a very kind of naive way of doing it. I think that maybe a natural question that comes out of that is like, well, like how does this scale, right? When you have so many requests coming in. And so that's really what the engineer's job is to do, right? To figure out what's to experiment with the system, figure out what's the right balance here of like how much you give the system versus how much you don't. Um, and so I guess one last example that I think is like interesting to look at is what if things come in out of order? So let's do like Scale AI and Temporal reconstruction. These examples are obviously super, super interesting. But let's look at one kind of final example here. So once again, things start coming in. And I think one thing as well to note here, right, is like this interface still kind of looks like a chat, right? It still kind of feels like a chat, but it's got some elements that maybe make it a bit different, right? Like being able to view docs, being able to have like a map view. And so I think what we're trying to show here is kind of a step in between like chatbot to full-on dashboard. What we imagine this world looking like is really just like a dashboard that shows all your AI agents and maybe kind of some sort of inbox with agents telling you what's going on. and you sort of responding to them. It looks here like, let's see here. So basically, we have some flooring materials. We got an approval, shipment departed, the shipment arrived, and then we got basically like it looks like we got another approval for the same flooring materials. And so the AI agent is smart enough to say, hey, like this is happening again and we already got it, right? So it's like at this point, this is exactly kind of what we mean by these paths and these workflows might feel deterministic, but because we have an LLM really looking at this, they don't have to be, right? So in this case, like maybe someone sent the signal again to approve it, and so the AI agent is saying that's kind of odd, like we already kind of did that. So it's asking the human being, what should we do? So
And
we can say like,
and
yeah,
pausing on that before you send it, sorry, Daniel. As a card-carrying temporal employee, I have to ask, and you may have been getting to this, like if you were to kill the worker at this point, like if you would actually stop the code that was running this, and again, you may not be prepared to do this. We're doing this live. Um, is this workflow going to survive? Like,
yeah,
it's backed by temporal, so my intuition says that if you were to just like kill the worker that's behind, like that's actually executing this code, that we're not going to have trouble. Like, it's waiting a day, I guess, for your response, like with the timer, from what I can see in the interface. But can you talk us through that and even try it if you're brave?
yeah. I think I just stopped it actually.
Oh, nice, nice, awesome.
So I kind of just stopped the work in the background. Let me start it up again. And the answer is yes, of course. Like it will sustain. So like right now, kind of the way I've done this, which I think is like interesting, is like I've created a tool, right? And this tool is essentially waiting for a day because I specified it to be a day on an external event to come into a queue, right? And so once that event comes into the queue, then it can actually go ahead and keep going. And so I just stopped it and it kind of resumed. And that's kind of what this gray area is representing here, that I actually stopped the worker and came back to it. And so here we can say, yeah, sure, like ignore. Um, this this doesn't make sense. You're right. Obviously, I'm kind of personifying a little bit the agent. That's just to make this a little more fun. But and it keeps going, right? And so the idea really is that of course we can stop these things, and that's kind of by design. And I think there's also another advantage to this, which is that we can also scale things up, right? And so I think that becomes a question a lot in enterprise settings. It's like, okay, I understand how temporal works, but like why is this so powerful? And one of the big reasons is that we can scale this up as much as we want. Like let's say we start seeing people use this procurement agent a ton and it becomes like we start to hit some sort of like capacity issue, then that's where we can just kind of add more workers, which is really, really helpful. Um, and so that's kind of what I wanted to show for the demo piece. But I think the natural question and the question we hear with enterprises all the time is, well, okay, cool demo, but how do you guarantee like how do you guarantee that this works for real, right? Like how do you guarantee that this works in production? How can you give me confidence that this is the when I release this to the world that it'll actually do the right thing? And so the answer to that, everything we've been looking at right now is kind of agentics and sort of agent execution, right? Which is this first half. But as part of what we offer here with Scale, and this is not something that's unique to Scale, right? This is something that's very much in the industry, is this second piece around observability and evaluations. And this is kind of the key word, evals. And so I guess the best way to think about it, and one thing that's really stuck with me is like traditional software is something you can specify. So you can write tests for it, you can expect exactly what things are going to look like. But kind of the pro and the con of using an LLM is that because it's more flexible, right? That also means that you don't really know exactly what it's going to do. So how do you make sure that you can test that? And so that's why you create evaluations where you really specify exactly what you want to test. And so for this demo, I've actually created like a small evaluation, right? And the evaluation is really looking at kind of what we looked at in this demo, which is essentially like let's look at all these events, make sure that these events are doing the right thing, and also look at kind of edge cases, like what happens if an inspection fails, what happens if something goes out of order, all those kind of things. And so let me see if I can open this up. There is a small chance that it does not work, but we'll try and see if it does. Um, do, 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 do. Awesome. So here's kind of like our evaluation. And this is done in a very kind of naive way, right? Like this isn't anything too special. This is literally just using like Python and kind of vibe coding using Claude. But I think and also I agree, not super pretty to look at, but we're really trying to show like the different things that we tested, right? So we have here like you know, a human approving something, the steel beams, like things arriving, things departing, submittal orders, all these kind of different events. And then we've also kind of mocked what a human being would do when it responds to things, just kind of using a static, just like a static response. Um, you can also do this with an LLM if you wanted to make it even more realistic. But I guess there's kind of two dimensions that we kind of test against, right? So the first part is like, do we want to create an evaluation that tests all our examples, or do we want to create an example for each of them? And in this case, what we're doing really is that we're doing for each of them. So we're saying, okay, for the shipment arriving, we want to test XYZ. And so that brings us to the second dimension, which is you can either do things programmatically or you can do things with an LLM. And so in this case, the way I've done things is actually programmatically. So what I'm checking is like, okay, something departs from the factory. I'm expecting, these three tools to be called because it doesn't matter what order, but these are the three tools I expect to be called. And then I'm expecting this to be the end state in the database. I don't care how the agent gets there, but that's kind of needed for this to work. And so the other way of doing things is using an LLM. And so if you have something a bit more subjective, right? Like let's say you're using an LLM to write advertiser copy. In that case, it's going to be a little harder to use like, just like code to test it. You might need to look for specific criteria, right? Like is this feature being, caught? Is the brand name being included? And so you create kind of these rubrics, which again, you're not saying like I think I see this a lot when people create evaluations that they create kind of like a 1 to 5 slider of like, is this good or not? Which is not very helpful because at the end of the day, an LLM can say two the first time and three the second time, and how do you measure that, right? So when you kind of use LLMs to really evaluate things, you want to create very specific points about things it should look for and kind of have some sort of true false way of checking that. Um, so anyways, all that to say that this is how we test, right? This is how we say like, I feel much better about putting this thing into production, even though I have a couple failures, which is actually okay because that actually gives me something to hill climb against and to actually improve my agent. But that way I can say, okay, look, for all these tests, I know it's working. I know it's doing the right things. And so kind of like the next step here is like, okay, that's great. We built our agent, we created this data set, then we deploy it into production. And so kind of this last step, right, is that we actually see what people do with it. And this is also super important, which is we can have all these ideas of what we think our agent is going to do, but the moment we put it into production, we see, oh, we didn't even think about that use case, or oh wow, this is going in a totally different order. And so that's where we just continue to iterate, right? We take those traces, we convert them into more data sets, and we continue to make our agent better for the real use cases that it's being done for. And this is really how we build things at Scale AI. This is how we power, Fortune 100 companies doing AI solutions. It's not super complicated, I think, but um, it's effective, right? And it's really just an iterative process of experimentation. There's no like one size fits all for how you do this.
I think that's the big point as well. Um, you can build agents and you can have them run and you can have them succeed in a constrained environment. But if you really want to do it in production at scale, you're going to have to use evals. You're going to have to iterate. You're going to have to collect some data en masse and then tune and tweak. There's no way to avoid it with these, probabilistic LLMs and running in chains doing their own reasoning. There's just no way to kind of, you really need to go through that effort of the science almost of it, like the experimentation and the iterative improvement.
Yeah, and I will say it's not fun, right? Evals are like it's not the sexy part, but it's super super important. And it also kind of gives you a way to say like, look, my agent's like for this case, right? Like my agent is performing well in all these test cases, and let's say later on in the future we realize there's something else that we wanted it to do. We don't want it to go backwards on the stuff that was already working. So without having sort of like this way of grading or this kind of rubric or measurement way of looking at things and very systematic approach, then you kind of lose that sometimes and you start regressing. So it's also important from that point of view. Awesome. Well, I think that was most of it as far as the actual demo and kind of the presentation. I think we're going to move on to some questions here. I can leave this slide up, Steve, if you think that's best, or
Let's cut the slides maybe for now, and we'll do a chat, and then I think we have another slide about our conference later on that you might want to bring up. We have a hard stop in 13 minutes. I don't want to interview you for the duration of that because there's been some great questions coming in. So here's what I'll do. I'll ask you like a few questions that I've been burning to ask you, and I think others might want to know. And then we can go through to some of the audience questions as well that are definitely coming in. So to begin with, I really want to know what types of customers and industries are using Scale AI and specifically Agentex and kind of is what's drawing them to it and what's the kind of experience of working with those folks to sort of build out their agents.
Yeah, I mean, I think we're working with a bunch of different kind of industries, right? We're doing some stuff with healthcare, we're doing stuff with like education, energy, financial services, telecommunications. It's kind of really all over the place. But like as far as where I've seen Agentics really come in, I've seen it for two use cases. One is kind of in this kind of financial services. I can't name the companies, obviously, but we'll just kind of say a broad financial services. And so the project we've been looking at is this idea of basically being able to do some sort of like research into like companies and finding out evaluations for different companies. And so this is a process that takes a long time, right? This is something that takes like a month or two. And there's tons of different documents that come into the system and different people as well, kind of putting things in. And so the idea really is to have this AI agent that can take all of these things in and really reason about it and really understand, okay, for this company, this is the correct like evaluation, this is the right price, this is the right part. And so you have a bunch of different stakeholders all inputting things into the system. And so that's one use case where I've seen a long running agent, which has been really interesting. Another one that I've seen is kind of in energy. And so this is really about like drilling holes in the ground. And so it turns out there's a lot of planning to do to get there, right? And so it's like a multi-step process that takes a long time, like again, like months at a time with tons of different documents, compliance, all these different parts. And so having an AI system that can survive for that long and can understand and can correct and change things around it is also has also been super interesting to look at.
Perfect. And yeah, I think one thing you call out there is that context is everything. You need to know the businesses, you need to know how they run, you need to know the industry they're in. There's just kind of no shortcut around that. Um, all right, so what am I going to ask you next? All right, cool. What was the experience like, I guess, adopting temporal for those parts, to kind of underpin Agentex as an option? Was that like I mean, I imagine there was a learning curve. My job is to sort of help people get started with temporal, so there definitely was a learning curve, but I'm wondering what that was like.
Yeah, not to sound too like I'm blowing smoke, but I do think it was really fun to learn. Like I personally love learning, and so like when I started looking at temporal, like I started with the kind of 101, 102 videos that you have on the website, which were really great, and I found it quite enjoyable, and the constructs kind of made sense to me. I think the surprising part and something that I see other people also kind of be surprised with when I explain how temporal works is the fact that temporal doesn't actually run the code, right? It's kind of this orchestration layer. I think that was one kind of thing that I had to like understand, especially when I started looking at the architecture. It was like, oh, I see. You guys aren't running it for us, which actually makes a lot of sense from a security point of view, but something that wasn't intuitive when I first kind of looked at it.
I think it's probably the greatest misunderstanding I come across, which is yeah, you as a temporal user, you run your own code, and you can encrypt your data payloads back and forth to the service. And so for something like Temporal Cloud, which is our paid for SaaS service, just because you're using that SaaS service doesn't mean any data, like unencrypted data, is getting to the temporal like cloud service, and it's all encrypted with your own keys. And so this is how we get like massive check marks with security teams from like healthcare providers and banks and other institutions that are like heavily regulated and sort of need that level of they cannot share sensitive information. Like it cannot leave like their businesses. Yeah, so I think I agree with that, and I think temporal we need to be a bit louder about that aspect as well, because some people look at that and go, oh, we could never use temporal, or we could never use temporal cloud because of this and that, but that's on us. Daniel, the last question I'll ask you before we get on to like I know there's a bunch of questions coming in, so we'll try and get around to them. And if not, we'll answer them after this webinar. But what is the most? I mean, there's a bunch going on in AI. What is the most exciting, I guess, non-scale AI thing that you've used or seen in the last like month or two? Something that just kind of blew you away.
Sure. I mean, to me, the most exciting thing in AI right now is like coding agents. I think it's like super, super interesting. Like, obviously, having tools in a loop works, right? It can do real world stuff that's helpful. but extending this to think about like having an agent use code, not necessarily to write code, right? To do really anything, is super interesting, right? I think like Anthropic is doing a lot of work around this. And kind of maybe related, that there was a really good paper about RLMs that came out recently, which is similar in the sense that it's kind of just a harness that uses, code to, create like this kind of like external environment variable out of a really long context window. But it's really just allowing your agent to use the tools that it has to explore something on its own. And it seems to be super effective. So I found that like that's something that I'm thinking about a lot. Yeah.
Yeah, me too. It's kind of funny how file systems and Unix tools have like come back in a big way just because it turns out that agents know how to use them really well and that's where a lot of the power is and I'm also excited by that. And it's not just coding agents that I think that's just where it started and we're going to see it sort of for general work soon and sort of these up-leveled abstractions that non-coders can take advantage of to do non-coding work. Um, awesome. Thank you, Daniel, and thank you for the demo. I do have a bunch of questions here. The first one from the audience, the first one being from Tommy, which is how are you stream? Like Temporal doesn't inherently support streaming at the moment. I can tell you that it's coming. Actually, it's roadmapped. We're going to do it, but it doesn't natively support streaming tokens. And so, how did you achieve that with this demo, for example, and with the Gentex?
Yeah, so the way we do it with Agentex, right, is that we have we basically spin up Redis as part of our kind of Agentex framework, and so we have like we use Redis streaming. We have like our UI actually like creating the subscription to the Redis stream using a task ID that we persist for every kind of conversation, and then in that way, when the backend sends things to Redis, it immediately gets kind of to the front end.
Cool. So you've got this kind of like the actual streaming's taken care of by like Redis pub sub or something like that. Um,
Exactly.
okay,
Exactly.
perfect. And we Temporal actually has a sample that a colleague of mine wrote around that, around Redis specifically. So I'll share that after this in the follow-up email as well. Awesome. All right, next question. I think there's a question here about the learnings based on the answer feedback that you
Yeah.
gave, and whether, this is from Scale or did someone did the person writing the procurement agent have to implement that as BYO logic? And so like because it's so contextual, right? These use cases are so contextual. Is it generalizable in a way? Does the Gentex kind of support it as some kind of primitive, this kind of self-learning thing? Can you talk about that?
Yeah, it's a really good question. I mean, like the answer is no. We don't support it as a primitive. It's not something that we kind of do like that. I think the reason for that is because it's something that you kind of have to fine tune so much to get right for your specific use case, but it is something we could probably look at. But I think like the idea of it, right? And I think anyone who, writes agents or writes code like this doesn't I don't think it's too crazy, but it's really just about like looking at your conversation history, right? And having as far as like every time like the turn kind of ends or something happens, you have this kind of second LLM or not even LLM, really just code that looks at, hey, was the human called? Did the human being do something here? If the answer is yes, then that context is put into another LLM. The actual learning is extracted, and then that's put into kind of like an environment variable. And then we kind of mark that in our conversation history as like, look, we already did this. So if the next time around, if when that kind of function is called, it's not going to go and extract the same learning over and over, and it's also not going to go backwards and find stuff that's way too like old. So it's kind of like it's very much just like an engineering thing of like marking things, keeping track of things, kind of like it's simple. Yeah, it's nothing that crazy.
Awesome. So it is contextual to the demo, but the demo itself is open source, correct?
It is, yeah. I
Yeah.
guess I totally forgot to mention that, but yeah, Agentic is open source. Our SDK is open source. In our SDK, we have this procurement agent example, which you can go in and take a look at. All the code is there. Also, like side note, open code, which is essentially like Claude code competition, really interesting as well. Also, like open source, if you want to learn more about context management, compaction, you can kind of really see, okay, how are these things actually being done?
Perfect. Yeah, this whole thing's open source, including the framework. Is the big lesson here, and of course we'll share out those repos as well after this. Um, I think we have time for one. I think one. Yes, one answer from you, Daniel, and I'll do a couple of quick ones first, just to like kind of check them off. So I'm seeing it'd be great to have an inbuilt context management solution with multimodal data becoming popular. Temporal's payload limit, which is 2 MB, will be a bottleneck. Yes, there are ways around that, but we are actually shipping a first-party feature to do large payloads. So look out for that. It'll be private preview pretty soon, actually, so we can talk more about that at another stage. Indeed, we can demo it in another webinar as well. So that's exciting. And then I think that's probably all I wanted to answer. Daniel, final question for you. How does Scale AI help against prompt injection? For example, documents that humans might submit that might have malicious prompts or something like that in it. And how do you think about guarding against that?
Yes, yes, that's a huge part of what we do. Like we have actually a whole team, which we call our kind of red team. And so they do this thing called red teaming, which really just means they go in, look at an enterprise AI solution and try to break it. And more than break it, they try to do malicious things. And so then they try to find those kind of vulnerabilities and give suggestions for that company or for that team about how they can, make sure that those things don't happen, basically. Um, because obviously this is something really real with AI systems.
Yeah, and again, at production at scale with big regulated industries, perhaps it can be catastrophic to get this wrong. So it's worthy of a huge amount of attention and protection. Okay, so I don't want to get kicked out of here forcibly by Zoom, so I'm going to thank everyone sort of in the audience for watching this, checking out Agentex and Temporal and the demo, and also for the great questions, which we will follow up on anything we didn't get to. We'll make sure they're answered and sent back out with the recording and all that. Mostly, I very much want to thank you, Daniel, for coming by and just telling us about Agentex and just agent building in general. This space is very nascent, people. It's moving fast, but it's the early days. And so I think what I see here with Scale AI is kind of at the forefront. And so thanks again for being here.
Thank you so much for those words, and thanks so much for having me, Steve, and Temporal team. That was really fun.
Awesome. You're welcome. We'll have you back at some point to show us something else. But without further ado, thanks everyone. Bye.